1.1 Investigating Viscosity. Fluids can be found everywhere. We drink them, we breathe them, and we use them. But how much do you know about fluids? In this big idea, we will have an opportunity to investigate an important property of fluids called viscosity. The particle theory of matter attempts to explain matter in a number of ways. It describes a model of matter, the different states of matter, and what happens when matter changes from one state to another. We talked about this concept before the break. This model helps us to understand and explain observations that we will make when investigating matter. So you guys will probably remember we have solids, such as rocks, where all the pieces are very structured and they're held together, but they're constantly vibrating. Then we have liquids like water on a water slide. Those particles are moving around a little bit more. Then we have gases, and those are moving around really fast and all over the place. The particle theory describes how particles behave in each of the three states of matter. When a matter is a solid, the particles are close together and fixed in place. In a liquid, they are close together but can slide around and over each other. In a gas, the particles are far apart and move around rapidly. A brief review of particle theory is on the right. So we made a one-page summary of this, but just quick points. All matter is made up of tiny particles. Different substances are made up of different particles. The particles of matter are always moving and vibrating. Particles move differently in solids, liquids, and gases. And adding heat makes particles move more and vibrate faster. As a result, the state of matter may change. So the warmer something is, typically the closer to a gas it becomes. Can the particle theory be used to describe fluids and how they behave? And what exactly are fluids? Most people think of liquids when they hear the word fluid, but gases are also fluids. In fact, we can think of a fluid as any matter that has no fixed shape, but that takes the shape of its container. For example, the air in a bicycle tire takes the shape of the tire. The air in the beach ball takes the same shape as the ball. In the same way, water in a bottle takes the shape of the bottle, but in a bowl, it takes the shape of a bowl. In this unit, we will investigate properties of fluids. In many of these activities, you will use particle theory to help explain your observation. Before we go too far, we do want to touch a little bit on safety. So before proceeding with the investigations of viscosity, you need to think about safety. There are many fluids that are safe to handle. We eat them, we put them on our skin, and we swim in them. There are, however, some fluids that are unsafe. There are two different labeling systems used in Canada to help us know which foods are safe and which will need to be handled cautiously. At home, you may have seen the Hazardous Household Product Symbols, or HHPS, on cleaning or automobile fluids found in your garage. These symbols tell you the level and type of danger, so poison, flammable, explosive, corrosive. If you were to go through wherever you guys keep your cleaning products at home, you would probably find almost all of those symbols on those cleaning products. In all workplaces in Canada, including schools, you will see the second type of safety symbols. They are the Workplace Hazardous Materials Information System, or WHMIS, safety symbols. You will see these symbols in your classroom, and it is important to know what they mean. Understanding WHMIS symbols can help you handle dangerous materials safely. We talked about these a little bit earlier this year, but I will go over them. So there's flammable materials, oxidizing materials, which are materials that catch fire when exposed to oxygen, materials under pressure, corrosive, explosive or reactive materials, an environmental hazard, presence of organisms or toxins that can cause disease, so that's a biohazard, hazardous materials that cause less serious health effects, products that cause serious health effects, and hazardous materials that cause death or acute toxicity with small amounts. It is important to stay safe in the science lab. Check the label of all materials to determine whether they are potentially dangerous. Viscosity. One property of fluids is how they move or flow. Think about the food you've used in the last couple of days. How would you be using them different? The fluids. I'm sorry, guys, that's a bad typo. Think about the fluids you've used. How would you be using them different if they did not flow the way they usually do? For example, what if soda pop was like a thick syrup or ketchup was like water? In both these situations, the properties of the fluids are dramatically different. How fluids flow is determined by a property called viscosity. Viscosity is a liquid's internal resistance or friction that keeps it from flowing. Recall from the particle theory that the particles in a liquid slide around and roll over each other. In a gas, the particles move around more easily because they are far apart. In a fluid, the greater the friction or rubbing between the particles, the higher the viscosity. Fluids with a high viscosity do not flow as easily as fluids with a low viscosity. There are several ways to determine the viscosity of fluids. Two common ways that you will investigate are the bubble test and the ramp method. In the bubble test, you time how long it takes an air bubble to rise through a tube of fluid. I have a video for you here. It's not the bubble test, but it's actually a marble test, but it's kind of similar. So if you want to watch that, it kind of gives you an idea of what that might look like. And in the ramp method, you time how long it takes a fluid to flow down a ramp. So we're actually going to do an experiment with that tomorrow during our live class time, where you guys will have to do a lab report to complete that. The longer it takes for the bubble to travel through a fluid, or for a fluid to flow down a ramp, the higher its viscosity. When you are performing a scientific investigation, such as a bubble test or ramp method, it is important to control the variables, or the things that can be changed. You will be performing a fair test when you ensure that only one part of your experiment or one variable is being changed at a time. That way you will know that the changes you observe are due to the one variable you are changing. For example, if we were testing out running shoes and we wanted to know which shoes made us run the fastest, if we had the same student try on all the different shoes and we timed them with each of the different shoes, that would be a fair test. If we put a different pair of shoes on every single student and then use those times, that would not be fair because not all the students in our class run at the same speed. Viscosity is important. Viscosity of a fluid is important. For example, when you are cooking, you can change the viscosity of gravy. If the gravy's viscosity is too low or if it's too runny, you need to add more flour. If its viscosity is too high or if it's too thick, you need to add more water. So what causes some fluids to have higher viscosity than others? Think of how glue feels on your fingertips, like white glue. It feels sticky because the glue particles are attracted to your skin. Similarly, certain types of particles attract each other more than others. It is hard for these particles to flow or move easily by each other. Even though all fluids flow, the greater the attraction between particles, the higher the viscosity. The attraction between fluid particles is related to their size and shape. Small particles can move past each other more easily, resulting in a lower viscosity. As well, some particle shapes flow past each other more easily. So if you think about if I have a container full of marbles or buttons and a container full of yarn strands, if we dump out those jars, the marbles or buttons will easily move around each other and they flow through. So I could shake out a few pieces, a few marbles or a few buttons out of there. But the yarn strands, it's going to be a lot harder because they're going to get stuck against each other because they actually are more attracted to each other. This result is similar to the effect of particle shape on viscosity. So it works the same with all the very teeny tiny shapes that we have inside of different fluids. And they are going to either run over top of each other easily or they might kind of stick to each other as they go. So we have a couple of questions here that I would like you to answer. The first question is to write a short paragraph, so you need 5 sentences to describe viscosity. So you need to include at least 2 examples of fluids, so give me 2 things that are a fluid. And your your description should use the words flow, fluid, particles, and viscosity. So it needs to include those 4 words. The second question is asking you about viscosity. So which of the following materials is the most viscous or is the thickest? Okay, which is the least viscous or which is the thinnest? How could we determine that? So remember, something that has lots of viscosity or is the most viscous would be something that is hard to pour, and the least viscous would be the one that is easiest to pour. Number 3, describe 2 substances that are useful because of their viscosity. And so what criteria would you use to determine if a brand name substance is high quality or not? So some things are helpful because they are thick. So think about 2 things that maybe it would be important and how we might be able to tell by looking at different brand names and their viscosity if it's good quality or not. And the last one, how can you ensure a fair test if you are trying to compare the viscosities of 2 different substances? So we talked about that idea of a fair test. How can we make sure that we are giving a fair chance to all of the substances or the 2 different substances when we are testing them? So answer the questions. If you're doing it online, you may need to make a copy of this so that you can type it on, or you can answer them on a piece of loose leaf, whichever works for you, works for me. If you have any questions, please let me know.